So good morning everyone. So in our last class, uh, we discussed uh, the very basics of databases, what actually is a database, and also the management system. Uh, Today we shall start the first module. So it includes three chapters: Introduction to Databases, Overview of Database Languages and Architectures, Conceptual Data Modeling using Entities and Relationships. So within that, we will start the first chapter, that is the basics to databases. So databases have many applications. So few of them include numerical and textual databases, multimedia databases, GIS databases, warehousing, and OLAP databases, and real-time databases. So these are the category of databases depending on their application. So for example, in traditional database applications, so information is stored and accessed either as a text or as a numerical. For example, the chat window which we use is a textual database where everything is stored as a text file. So which means anyone can read them. So numeric means the numbers are stored. So it may be a mixture of numbers and text. So in yesterday's example, we saw how we typed the subjects followed by the marks in the chat window. So such kind of things are called as textual databases. So here we are talking about the database, not the database management system, because the management system is a software. So database is a collection of data. So multimedia database include the images, video clips, audio clip, so all those things. So if we are storing and processing them, it becomes multimedia database. So a famous multimedia databases include the applications such as YouTube, Hotstar, Woot, Netflix. So all those things deal with the video files. So that is an example for multimedia database. So next is GIS. So GIS systems um, include the storage and analysis of map, that is a geographical information. So geographical informations include uh, analysis of maps and weather reporting, as well as satellite images. So anything through which we specify or indicate a geographical location, so it becomes a geographical information system. So data warehouses and online analytical processing databases. So these data warehouses are the large set of data which are used in many companies to extract and analyze the useful information from very large database for decision making purpose. So this online analytical processing, it is mainly used for reporting and analysis. So it is also part of big data. So for example, if we consider the online shopping sites such as Flipkart and Amazon, so using the transactions or the order history of a user, so some analysis can be done. So which means whenever a user buys a particular product, what is the related product the user is going to buy in a near future. So all those things will be suggested for the user. So in all the pages. So such applications are an example of analytical processing. So the last category of database is the real-time and active database. So as the name itself suggests, it is the real time. Real time means as and when it happens. So it is predominantly used in industries and manufacturing processes. So where the data needs to be analyzed and it has to be accurate with the time. So if data is attached with a time and some processes has to be completed within the time, so such databases comes under the category of real time and active database. So maybe one such example for these kind of real time databases include the stock market data. So where every second crores of rupees transactions will be happening and the share prices will keep on changing, either rises, decreases. So happens, this change happens for every microsecond. So these are the various applications of databases. So next let us see the basic definitions related to database. So as I mentioned in the uh, previous class, so database is a uh, collection of data. So here data means it is an information. So data is known fact that can be recorded and have a meaning. So it is nothing but the information. So anything we can store is a data. Maybe when we are talking about a person, all the details about that person which can be stored on a digital platform becomes the data. Maybe his name, age, date of birth, address, phone number, email ID. So all those things, blood group. So they are all part of data. So whenever we create applications, so we will be using some domain. So if we are discussing about the college database, so our domain is fixed, which means what are the things we need to store, that only those will be stored. So that domain is called as, or the boundary uh, which we create is called as a universe of discourse. So universe of discourse is nothing but it is a part of a real world about which we are storing the database. For example, the same university database or college database. So those two are part of the world. And when we build applications, we will be collecting the data pertaining to that particular entity. So that becomes the universe for that particular database. So when we talk about college and university, we store only the very basic informations about a student, maybe the faculty members, the results of the students. So we are limited to these. We will not be storing the informations that are not necessary for the operation of a college or a university. So such information may be including the assets and liabilities of a student, maybe the banking transactions. So all those things are not stored because that is not required for the application. So whatever the things which we store when we are building an application, so that becomes the universe of discourse. So finally, DBMS is defined as a, yes, DBMS is a software. So it is a collection of programs that enables the user to create and maintain the database. So database is a general purpose software that has a functionality of defining the data, constructing it, alter it, and share it with the users or other people. So it is a complete software. So the software is called as a database management system. So sometimes whenever we are discussing, so we alternatively use the word database for database management system. So whenever we say database, it is the database management system about which we will be talking. So next, so let us see the functionality of the database. So now we know what is a database. So next we shall see what is its functionality. So let us assume we want to collect the information about all the students. So when we want this particular information, we need to decide what information we are collecting. So that becomes the attributes. So whenever we are storing them, we need to decide the data type of the each information we are collecting about a student. So for example, a student name, it is of a string type. Does it contain the digits or special characters? No. So that restriction or a rule is called as a constraint. So here we have encountered a new term, that is constraint. So constraint is nothing but a restriction. So whenever we are defining an information, so we need to decide about its data type and the rules. So whenever we are storing the mobile numbers, so the rule is it should not contain the alphabets. Or whenever we are storing the age, again it should not contain the alphabets. So all those things becomes part of the data type and the constraint. And let us assume we are collecting the information about 100 students. So we are collecting everyone's mobile number. What are the constraints on that mobile number? First thing is it should not contain the alphabets. It should contain only digits. And the second thing is when we collect the 100 phone numbers, each number should be unique, which means no two students should have a same mobile number. So again, that is also another rule we are imposing on the information that is being collected. So that is also called as a constraint, and we call it as a unique constraint. So another functionality of DBMS include the construction and loading of data on a secondary storage. So once we define the data and we enter the data, finally it has to be stored somewhere on the hard disk or a hard drive. So that task is of the software, that is DBMS. So it should store the data on the hard drive and also retrieve it. So another functionality that the DBMS should provide us is the uh, manipulating of databases. So manipulating means inserting a new student details, deletion of existing student details, modify some of the information of a student, at the same time generate the reports, and also if you want to extract any particular information, so we can use the queries. So these features should be present in a DBMS. So another very predominant functionality includes concurrent processing and sharing. So concurrent processing means more than one user may access the database at the same time. So then the database software should have the ability to serve these two requests at the same time. So for example, whenever VTU results are announced, so thousands of students will start entering their USN to check the result. So at that time, the database should be able to process all those thousands of requests at a same time. So that becomes concurrent processing. And sharing means, so there may be a multiple user or applications for the databases. So which means the same database can be altered or modified by different set of users. So each DBMS software will have a separate login for different users. So that facility is called as sharing of data by the users. So these are the functionalities of uh, database management system. So we have other features related to DBMS. So they include metadata. So metadata means it is the very small information about the data. So it is just like a catalog. So catalog will have a small information about a product. So if we have a small information about a data, that becomes the metadata. So whenever we are collecting the student information, so we will be collecting the USN, name, mobile number, email ID, maybe followed by a date of birth. So these five becomes the metadata about the student data or the catalog. So the another feature that this software should provide is a protection or security measures. So each user to database will have their own username and password, so that it prevents any unauthorized access to either read the data or edit the data. So another thing is active processing to take internal actions on data. So this active processing means, so without user doing anything, the internally the DBMS packages will perform some actions. So those are called as assertions and triggers. So which we will discuss in due time. So actions performed by the DBMS on its own is called as active processing. So presentation and visualization of data. So it means whenever a user wants to see the data, so the data must be presented to the user. So that becomes the presentation and visualization of data, maybe associated with some graphs. So these are the few additional features that a database management software that must provide. So let us look into some conceptual data or database. So let us uh, take the example of a university database. So here the mini world, the universe of discourse. So that becomes the university. So within that, we will be having some entities. So student, course nothing but subject, sections, departments, instructors, maybe faculty. So all those things. So these are called as entities. So if you observe each one of them, they have an independent existence. For example, a student has an independent existence. Courses will have their own independent existence. If nobody is taking that particular course or that particular subject, so it is still present in the mini world. So it is not related to any other entities over there. So similarly, sections, department and instructors. So each one of them have their own independent existence. So those we call it them as entities. So during the um, this course, you will get to know these kind of words. So what is an entity? So all those things and how to create an entity. And whenever we are building a database applications, so how to design the entities. So all those things you will learn in the due time. So when we have entities, there will be relationships between the entities. So that we call it as a entity relationship data model. For example, consider the entity over here, student and courses. So students will enroll to courses. So that enrollment is the relationship. For example, fifth semester students will be enrolling to certain set of subjects, that is management, computer networks, DBMS, Unix, Python. So a student enrolls to these particular courses. So that enrollment becomes the relationship. Then sections. So a student belong to a particular section. So whether the student belongs or not, section will have their own independent existence. So that's why it is a entity. And student belongs to that particular section. So that belongs to becomes a relationship. Then again student belongs to a department. Department has a sections. Department has courses. So that is the relationship between a department and a section, department and a course. So each department will have an instructor. So there is a relationship between a department and course. So each course will have an instructor. So there is a relationship between a course and instructor. So like that, each entities will be related to each other. So such relationships among the entities, we call it as a entity relationship data model. And in short form, we call it as ER, that is entity relationship. So this is a simplified DBMS system. So if you can observe this particular diagram, any application, any real world application is incomplete without the presence of a database, which means 100% of the real world applications which we build will have a database in one or other form. So here, so you can observe the user programs, so will interact with the DBMS system. So first what we will do, if we want to get the information about all the student entities, so the program will send the queries. So these queries are then forwarded to the DBMS software. So this software will process the query. So a simple query that we may send is select all the students or select names of all the students. So that becomes a query. So from the program, we will send the function call. So in the function call, what we are passing, select names of all the students. So that will be sent to database system. So this database system will process that and forward it to the DBMS software. So the software will further process the particular query. So based on that, it will search the hard disk where that particular information is present. So it will get all the students. Within that, it will extract the names of all of them. And then it is returned back to the user program. So this particular symbol, whatever we are seeing, cylindrical symbol, so this usually indicates the uh, database that is the on the storage, that is maybe on a hard disk. So again, if you observe, it has a two parts. So one is the metadata, another one is the database. So what are the metadata we have about a student? His USN, name, mobile number, email ID, maybe date of birth. So those five information are present in the metadata. So when we raise a query, select names of all the students. First, it will check in the metadata whether we have captured the name information of all the students. So if it is present in the metadata, then it will check the stored database. Because if we have not collected the names of the students, then it is meaningless, or it is just another burden on a processing system to search in the hard disk or the secondary storages. So first it will check the metadata whether we have captured it or not. If it is captured, then only the hard disk is checked for that particular information. Okay. So yes, so as I mentioned in our previous slide, this is the relationships among the mini world, that is the section or of a specific course. So student belongs to a section. So each course will have a prerequisite course. Prerequisite course means before studying any subject, some other subject should be completed. So that's like that. So instructor teaches a section. So courses are offered by the department. So student has a major in the department. So major is nothing but a belongs to a department. So all these examples which we discuss over here, uh, they are all written with regard to maybe universities or institutions that are in abroad. So the terminology, whichever, whatever we have over here, so that is all with regard to the United States, because the authors of the book are from there. So they will design the entire examples in such a way that uh, they have the all the terminologies belongs to their own system. So we have this particular word that is majors, instructor, teachers. Here we call faculty. In US they call them as instructors. So like that. So this is the example of entity relationship. So yeah, let us look at a simple example. So student. So two students are present. So the information that is being captured is a name, student number, class, major. So here student number may be equivalent to our USN concept. Class may be semester, major means branch. So course, again, course name, course number. So here, similar to the subject name, subject code, number of hours, and the teaching department. So where it belongs. So that information is stored. So section ID, what are the course that are being taught in that particular section. So whether it is a odd or even. So we call odd semester even semester, but in Europe and US they call it as a spring and fall. So depending on snowfall or whether it is a spring season. So that is how they define that particular concept. So year of establishment and the instructor who is present for that particular section. So these are the entities, and again entities will have a independent existence. So a student will Smith will continue to exist even though there is no course, there is no section, no grade report, no prerequisite. So if these four are not present, still the Smith will have an independent existence. So that's why it is a entity. So here prerequisite means, so in order to take this particular course, that is CS 3380, CS 3320 should be complete. So like that. So this is the example data. So here if you observe in the first row, we have the details about the data or the information about the data. So that is called as metadata. Here student name, student number, class, major. So these are metadata. And whatever we have inside, that is in the from the second row onwards, that is the actual data. So here in technical terms, so this data we call it as a data set. So each one is a set. So it is a set of values. So what is the value? Introduction to Computer Science, CS 13104 CS. So these four values becomes a set. So set of data, it is called as a data set. So how many data sets are present in student? 2. In course, 4. So again the new term, that is data set. So metadata. So throughout this particular course, you will be studying new terms which you might have not heard with related to computer science. So there will be a lot of new terms. So you have to remember them. Of course, it is not that complex. So this is a typical example. Okay. Okay, we shall stop our discussion for today till here, and we can continue our discussion on the main characteristics of database approaches in our next class.